Imagine a place where the ground beneath your feet is hot enough to melt lead. Where the air is so thick with heat that nothing, no machine, no probe, no rover, has ever survived longer than 2 hours. Now imagine the opposite. A world so cold that if you poured boiling water into the air, it would freeze into crystals before it hit the ground. Not in minutes. In milliseconds. Both of these places exist in our solar system. One is our closest neighbor. The other is a frozen giant at the edge of everything we know. Every planet in our solar system has a temperature story. Some are burning. Some are freezing. And some are stranger than anything you could imagine. This is the complete guide to the most extreme temperatures in our solar system, from the hottest surface ever recorded to the coldest atmosphere ever measured. Let's start with the closest planet to the Sun. You would expect Mercury to be the hottest planet in the solar system. It is not. But it does hold a different record, the biggest temperature swing of any planet. During the day, Mercury's surface reaches 430 degrees Celsius. That is hot enough to melt tin and lead. But at night, the temperature drops to negative 180 degrees Celsius. That is a difference of over 600 degrees between day and night. On Earth, the difference between our hottest and coldest temperatures is about 100 degrees. Mercury experiences 6 times that, every single day. Why such an extreme swing? Mercury has almost no atmosphere. On Earth, our atmosphere acts like a blanket, trapping heat at night and distributing it around the planet. Mercury has nothing. When the sun goes down, all that heat radiates straight into space. There is another strange detail. Mercury rotates incredibly slowly. One day on Mercury lasts 59 Earth days. That means the sun-facing side bakes for nearly 2 months straight, while the dark side freezes for just as long. If you stood on the border between day and night, you could literally have one foot in an oven and the other in a freezer. And here is something that will surprise you. Despite being the closest planet to the Sun, Mercury has ice. NASA's Messenger probe confirmed water ice hiding in permanently shadowed craters near the poles. In places the Sun has never reached, temperatures stay below negative 200 degrees Celsius, cold enough to preserve ice for billions of years. Venus is often called Earth's twin. Similar size. Similar mass. Similar distance from the Sun. But step onto Venus and you would be dead in seconds. The surface temperature of Venus is 465 degrees Celsius. Every single day. Every single night. At the equator and at the poles. There is almost no temperature variation anywhere on the planet. It is the hottest surface in the entire solar system, hotter than Mercury, even though Venus is nearly twice as far from the Sun. How is this possible? The answer is a runaway greenhouse effect. Venus has an atmosphere 90 times thicker than Earth's, made almost entirely of carbon dioxide. This atmosphere traps heat so efficiently that the temperature just kept climbing, century after century, until it stabilized at a level that can melt lead and zinc. The pressure on the surface is crushing, equivalent to being 900 meters deep in Earth's ocean. The Soviet Union sent a series of Venera probes to the surface starting in the 1970s. Venera 7 was the first spacecraft to successfully land on another planet and send data back. It lasted 23 minutes before the heat destroyed it. Venera 13 set the record at 127 minutes. The photos it sent back showed a barren, orange landscape of flat rocks under a thick, glowing sky. Scientists believe Venus may have once had oceans and mild temperatures, possibly for billions of years. Something triggered the greenhouse effect, maybe volcanic eruptions flooding the atmosphere with CO2, and the planet crossed a point of no return. All the water boiled away. The oceans evaporated into the sky. And Venus became the furnace it is today. This is why scientists study Venus so carefully. It is a warning of what can happen when a planet's climate spirals out of control. Earth sits in what astronomers call the habitable zone, the narrow band around a star where temperatures allow liquid water to exist. Not too hot, not too cold. Just right. Our average surface temperature is about 15 degrees Celsius. But Earth has its own extremes. The hottest temperature ever recorded was 56.7 degrees Celsius in Death Valley, California in 1913. The coldest was -89.2 degrees at the Soviet Vostok Station in Antarctica in 1983. What makes Earth special is not the average temperature. It is the stability. Our atmosphere, our oceans, and our magnetic field work together to keep temperatures within a range that supports liquid water and life. The atmosphere traps just enough heat through the greenhouse effect. The oceans absorb and distribute warmth around the globe. And the magnetic field shields us from solar radiation that would strip the atmosphere away. Without any one of these systems, Earth would look very different. Without the greenhouse effect, our average temperature would be -18 degrees instead of +15. Without the magnetic field, we would slowly lose our atmosphere to the solar wind, just like Mars did. Mars is cold. Much colder than most people realize. The average temperature on Mars is -60 degrees Celsius. On a warm summer day near the equator, it might reach a pleasant 20 degrees. But at night, temperatures plunge to -73 degrees. At the poles during winter, it drops to -125 degrees. That is cold enough to freeze carbon dioxide right out of the atmosphere, and that is exactly what happens. The polar ice caps on Mars are made partly of dry ice, frozen CO2 that forms directly from the air. Mars was not always this cold. Billions of years ago, Mars had a thicker atmosphere, warmer temperatures, and liquid water flowing on its surface. We know this because rovers like Curiosity and Spirit found minerals that can only form in the presence of water. So what happened? Mars lost its magnetic field. Without that invisible shield, the solar winds slowly stripped away the atmosphere over hundreds of millions of years. As the atmosphere thinned, Mars could no longer trap enough heat. The water froze or evaporated into space. And the planet became the frozen desert we see today. There is a tragic irony here. The same rovers we just talked about in our Mars documentary, Spirit, Opportunity, Curiosity, they all had to survive these brutal temperatures. Spirit's heaters failed in a Martian winter at -55 degrees. That is what finally killed it. Jupiter does not have a surface you can stand on, so measuring its temperature is more complicated. What we measure is the temperature at the cloud tops, and it is cold. About -145 degrees Celsius. But Jupiter hides a secret. Deep inside, the temperature climbs rapidly. At the core, scientists estimate the temperature reaches 24,000 degrees Celsius. That is hotter than the surface of the Sun, which sits at about 5,500 degrees. How does a planet so far from the Sun generate so much heat? Jupiter is still contracting. It is slowly shrinking under its own gravity, and this compression generates enormous heat from within. Jupiter actually radiates more heat into space than it receives from the Sun. It is essentially a failed star, a planet that was massive, but not quite massive enough to ignite nuclear fusion. The Great Red Spot, Jupiter's famous storm, has its own temperature dynamics. The storm has been raging for at least 350 years and is larger than Earth. Recent measurements show the area above the Great Red Spot is hundreds of degrees hotter than surrounding regions, possibly heated by acoustic waves from the storm below crashing into the upper atmosphere. Saturn is another gas giant, colder than Jupiter at around -178 degrees Celsius at the cloud tops. Like Jupiter, it generates internal heat radiating about 2.5 times more energy than it receives from the Sun. But the most interesting temperature story on Saturn belongs to its rings. The rings are made almost entirely of water ice, ranging from tiny grains to chunks the size of houses. Depending on whether they are in sunlight or shadow, ring particles range from -163 to -203 degrees Celsius. Saturn also has one of the most violent temperature events in the solar system, the Great White Spot. Roughly every 30 years, a massive storm erupts in Saturn's atmosphere. The 2010 storm was so powerful that it created a belt of superheated gas that wrapped around the entire planet. Temperatures in the storm's wake jumped by 80 degrees Celsius almost overnight. And then there is Titan, Saturn's largest moon. Titan has a thick nitrogen atmosphere, the only moon with a substantial atmosphere. Its surface temperature is negative 179 degrees, so cold that water is rock hard and methane flows in rivers and lakes. It rains liquid methane on Titan the way it rains water on Earth. Uranus and Neptune are called ice giants, and for good reason. Uranus holds the record for the coldest temperature ever measured in a planetary atmosphere, negative 224 degrees Celsius. This is strange because Neptune is farther from the Sun, yet Uranus is colder. Scientists think this is because Uranus was knocked on its side by a massive collision billions of years ago. It rolls around the Sun like a ball, and this unusual tilt may have disrupted the way heat flows from its interior. Unlike Jupiter and Saturn, Uranus barely radiates any internal heat. Something about its structure, possibly related to that ancient collision, traps heat inside. So the atmosphere gets almost no warming from below and barely any from the distant Sun. The result is the coldest place measured in any planet's atmosphere. Neptune, despite being the farthest planet from the Sun, is actually warmer than Uranus. Its cloud top temperature is about negative 214 degrees, 10 degrees warmer. Neptune has a strong internal heat source and radiates 2.6 times more energy than it receives from sunlight. Neptune also has the fastest winds in the solar system, reaching 2,100 kilometers per hour. These winds are driven by that internal heat engine, creating massive storm systems. The most famous was the Great Dark Spot, discovered by Voyager 2 in 1989, a storm the size of Earth that appeared and disappeared within a few years. Both ice giants remain the least explored planets in our solar system. Only one spacecraft, Voyager 2, has ever visited them, and it flew by each for just a few hours in the 1980s. There is so much we still do not know about these frozen worlds. From the lead-melting surface of Venus to the record-breaking cold of Uranus, every planet tells a different temperature story. And each one teaches us something about our own world, about how atmospheres trap heat, how magnetic fields protect planets, and how fragile the conditions for life really are. If this video taught you something new, hit subscribe and turn on the bell. We make videos about the most fascinating things in space every single week. Which planet's temperature surprised you the most? Drop your answer in the comments. I will be reading every one.